Hi, my name is Jordan Jarvis, and this is my Sped Talk. So, to get kind of into things, this project that I'm working on is my senior project. This is one of the one file of many. And what it does is it controls what are called multiprocessing queues. And many of you may have dealt with multiprocessing in the past or multithreading. I personally really like multiprocessing and multithreading when when something can be multiprocessed or multithreaded. I prefer to do it that way, even if it's not completely necessary. So with that, I needed to have something done for my project. My project actually requires a very high amount of processing to be done because it's image manipulation and trying to feed that image into a neural network after cleaning up everything and then trying to solve for words. It is a computer vision boggle solver. So there's a lot of stuff going on in the background, and I can't put it all on one thread. Otherwise, I would be getting maybe 1 or 2 frames per second at most. So I decided I was going to multi-thread it, multi-process it, and I came across these queues here. And what they do is they act like normal queues. The only real difference that they have from normal queues is that they can be passed into different threads and allows the threads to talk to each other using shared memory. So instead of having to allocate specific shared memory and do all this extra work, you can just make a queue and both threads can see it, or all threads can see it, and you can say, okay, well, now put this item on the queue and this other thread will take it off the queue and do some stuff on it, and you can just have them all checking the queues. So an example of why this is so useful is here. This program will put items on a queue for another thread that has to do a lot of image cleanup, manipulation, a lot of processing. And when I hit run, we're going to see a few things happen. So there's my face. This is my face after a bunch of algorithms has filtered out extraneous data to make it easier for the neural network to see letters and numbers in a grid pattern. So it's doing a good job, right? And it's using, each thread is basically maxed out, right? And if we look here, we go back to here, we can see that it's skipping hundreds of frames. It's only been running for a few seconds and we've already skipped hundreds of frames, which means that we're getting a very low frame rate. How do we increase the frame rate? Well, I'm going to stop the program and make it so we have more processes that those queues can talk to. So if I set it to 5, I'm going to hit run again. We're going to watch this. And all of a sudden, a few more processes are created. CPU overall utilization is higher, but you can see that we're not skipping any frames here. And if we go back to here, you can see that it's updating a lot faster now too. So by multi-threading, you're able to increase the frame rate. And many people don't like multi-threading because they don't understand how to move memory back and forth. Queues, totally the way to go. You just pass it in as a variable and you're able to talk back and forth, and it's able to accomplish basically whatever you need in passing data back and forth. So yeah, that is my Sped Talk, and hope you have a good day.